So I'm going to be talking to you about some of the problems that we see with acetazolamide, known as Diamox. And the main issues that we face when we're using acetazolamide is usually for papilledema, and usually it's idiopathic intracranial hypertension that we are giving. Normally our starting dose is 500 milligrams, and then we ramp up relatively rapidly to 500 milligrams twice a day. But you can go as high as 4 grams. Most of my patients can't tolerate more than 2 to 3 grams of Diamox. And the known adverse reactions that people complain about, which are the known side effects of the drug, paresthesias and tingling in the hands and feet, and a metallic taste in their mouth. They might have some fatigue. We don't stop the drug for these because that normally equilibrates relatively quickly in the kidney, probably within the first 2 or 3 days. The main things that we have to worry about are the metabolic acidosis that occurs from the Diamox. Fortunately, this is rare, and so we don't actually have to test patients on a routine basis with chemistries. Rarely people have had hematologic abnormalities, aplastic anemia, but we don't do the CBCs on these people because that's an idiosyncratic reaction from acetazolamide. There's no way to predict it, and it just happens randomly. And then the kidney stone. And finally, the patients who are quote-unquote sulfa allergic. So these are the main things that we have to worry about: the kidney stone, the sulfa, and the metabolic acidosis. As you know, Diamox is a carbonic anhydrase inhibitor, and what that means is it removes the water, anhydrase, from carbonic acid, and that means its major role is the transition state between H2CO3 and water, which is the anhydrous, and the CO2. However, if we block this reaction, then we're going to be forced to deal with the HCO3 minus and the H plus. And in the kidney, what that means is we have moving through the proximal renal tubule down through the loop and then around to the distal system. And most of the carbonic anhydrase inhibition is occurring in the proximal tubule. And so when we give Diamox, this is where the action is. And so the pumps are very specific. And so we can only exchange H plus for another plus, sodium. We are exchanging the HCO3 minus and chloride. And so the net result of carbonic anhydrase inhibition is we are dumping the sodium bicarbonate into the system, and that's going to produce a urinary alkalosis, and that is what is producing the metabolic acidosis. The metabolic acidosis is from the loss of sodium bicarb. However, as the sodium is being delivered to the distal tubule, when we get down to here, the sodium is going to want to come back, and that can only exchange with potassium. And so we're going to have potassium loss as a result of the increased, enhanced delivery of the sodium into the distal tubule. And so we'll have a hypokalemic metabolic acidosis from Diamox. Unfortunately, we don't have to deal with this very much, but when it does occur, we're going to replace with sodium bicarb. And potassium, we normally just tell them to get that from their diet, but you could give supplemental potassium. The kidney stone also operates from a similar mechanism. It is the urinary alkalosis that is producing the hypocitrauria, and that hypocitrauria and the change in the pH in the urine is what is causing the kidney stone, and that's going to change the calcium phosphate balance and lead to the precipitation of a calcium phosphate stone. So it's really important to try and catch the kidney stone in these people to determine whether it was a pH-related stone in Diamox. And the treatment here is to put the citrate back in. And so we can use potassium citrate to do that, or lemon juice just to acidify the urine and get the stone to go back to the calcium solution pH balance that we need. And then finally, the sulfa allergy. And people aren't really allergic to the S even though sulfa, the S, is contained in both Diamox and the other agent that we use, Lasix, the people are not allergic to the S. What you're allergic to is the thing we call the hapten. And the hapten is the N-arylamine group on the sulfonamide antimicrobial. So this moiety is what causes sulfa allergies. Sulfonamide antimicrobial people, this hapten is conjugated to the protein and leads to the allergic anaphylactic reactions that we see. And so if you are allergic to a sulfonamide antimicrobial, you probably can't have any agents in that same class. But because Diamox lacks this hapten, you could probably challenge this person with Diamox and see. However, there's some risk because they're an allergic person, but the same risk would occur if they were taking a beta-lactam or a non-steroidal. The hapten is the N-arylamine group. This is not present on the acetazolamide, and that's why sulfa allergic people are naturally allergic to sulfites and morphine sulfate and all sorts of other sulfa-containing agents, including Diamox and Lasix. So you need to know a little bit about Diamox, metabolic acidosis, the kidney stone, and the myth of the sulfa allergy.